Hello, my dear children. Hello, Bachcho, and welcome back. I know your exams are just around the corner and you're all working so hard. So today, we're going to do a super quick revision of one of the most important chapters, you guessed it, carbon and its compounds. Now, if you want more quick revision explainers just like this one, do me a favor, hit that subscribe button and tell me in the comments which chapter you want me to cover next, okay? Let's dive right in.
So, here's our game plan. First, we'll meet our hero, carbon. Then we'll uncover its two amazing superpowers. After that, we'll see how it builds millions of different things, just like Lego blocks. We'll also look at its most important chemical reactions. And finally, see where we use it in our everyday life. Trust me, by the end of this short explainer, this whole chapter is going to be crystal clear in your head.
So who is this carbon really? Bachcho, just take a look around you, seriously. The food you're eating, the clothes you're wearing, your books, medicines, even we are made of carbon compounds. You know, it's funny, it's only present in tiny amounts on Earth, just 0.02% in the crust and 0.03% in the atmosphere, but it's the building block of all life. It really is a superstar.
Now, what makes carbon so special? Well, its atomic number is 6. That means it has 4 electrons in its outermost shell, and to be stable, it needs a full shell of 8. But you see, gaining 4 more electrons is really difficult for its tiny nucleus to handle, and losing all 4 electrons, that would take a huge amount of energy. So, carbon's in a bit of a fix. What's the clever solution it comes up with?
The solution is simple: sharing. Instead of giving or taking electrons, carbon just shares its 4 valence electrons with other atoms. This sharing creates a really strong and stable bond, and we call it a covalent bond. It's just like when you share your tiffin with your friends during lunch break at school. You share some, they share some, and in the end, everyone's tummy is full and happy. This friendly sharing is the real secret behind carbon's nature.
Let's see exactly how this sharing works. Take a hydrogen atom. It has 1 electron, and it needs just 1 more to be stable. So what happens is 2 hydrogen atoms come close, and each one shares its electron. Now they have a shared pair between them, and voila! Both atoms are stable and happy. This is what we call a single covalent bond, and we show it with a single line. Simple, right? Okay, now let's level up and look at oxygen. An oxygen atom has 6 valence electrons, and it needs 2 more to be happy. So, 2 oxygen atoms will each share 2 of their electrons. This creates 2 shared pairs between them. This is called a double bond, and it's even stronger than a single bond. We draw it with 2 lines. Easy peasy. So we know carbon is a friendly sharer. But that's not all. It also has 2 very unique superpowers that let it form millions, literally millions of compounds. Let's uncover these secrets, shall we?
Okay, superpower number 1 is called tetravalency. Now, tetra just means 4. Because carbon has 4 valence electrons to share, it can form 4 covalent bonds with 4 other atoms, all at the same time. This makes it incredibly versatile. It's like an artist who can paint with 4 brushes at once, creating these amazing, complex pictures.
And its second superpower is even more amazing, if you can believe it. It's called catenation. This is carbon's special ability to form strong bonds with other carbon atoms. This allows it to create really long chains, branched chains, or even rings. Just imagine a long human train where everyone is holding hands very tightly. That's catenation. And you know what? No other element can do this as well as carbon can.
Now here, you can see the true power of bonding. Look at this. Both diamond, the hardest thing we know, and graphite, which is soft and slippery, are made of pure carbon. The only difference is how the carbon atoms are connected. In a diamond, each carbon is bonded tightly to 4 others in a rigid 3D structure. But in graphite, they're arranged in these flat hexagonal layers that can just slide over each other. Same element, but completely different properties. Isn't that incredible?
Okay, so now let's see how carbon actually builds things. Using its superpowers of tetravalency and catenation, it can act just like your Lego blocks, building an endless variety of structures: straight chains, branched chains, and even closed-up rings.
Now, these carbon structures can be one of 2 types. If a compound has only single bonds between its carbon atoms, we call it saturated. You can think of it as being full and satisfied, so it's not very reactive. But if it has at least 1 double or triple bond, it's called unsaturated. These guys are much more reactive because those double or triple bonds can easily open up to add more atoms.
Okay, Bachcho, pens down and eyes on the screen. This is a major exam hotspot. I can almost guarantee you'll get a question on structural isomers for at least 2 or 3 marks. So please pay very close attention to what's coming next.
So what are structural isomers? Let's take butane as an example. Its formula is C4H10. Now, we can arrange these 4 carbons and 10 hydrogens in 2 different ways. First, as a simple straight chain, or second, as a branch chain. See? Both have the exact same formula, C4H10, but they are actually different compounds with different properties. These are called structural isomers. It's simple, same formula, but different structures. It's just like using the same number of Lego blocks to build either a tall tower or a White House.
All right, so now that we know how carbon compounds are built, let's look at some action. We're going to quickly cover the 4 most important chemical reactions that you absolutely, positively must know for your exams. Okay, let's break these down real quick. First up, combustion. That's just a fancy word for burning. When carbon compounds burn in oxygen, they give off heat and light. It's why we use fuels like LPG at home. Next, oxidation. This is when we add oxygen to a compound. A key example you need to remember is turning ethanol into ethanoic acid. Third is the addition reaction. This is where we take an unsaturated compound, the one with a double or triple bond, and we add atoms to it, making it saturated. This is exactly how Vanaspati ghee is made from vegetable oils. And finally, we have substitution. Think of it like a substitute player in a cricket match. One atom gets taken out, and another one takes its place. Simple as that.
And finally, let's connect all this amazing chemistry to something we use every single day to stay clean: soaps and detergents.
So a soap molecule is basically a long-chain carbon compound with a very special design. It has 2 parts. It has a head that absolutely loves water. We call it hydrophilic. And then it has a long tail that hates water but loves oil and dirt. We call that hydrophobic. This split personality is the secret to its cleaning magic.
So when you mix soap and water, these molecules do something incredible. All the oil-loving tails rush to trap any oily dirt they can find, and they form this cluster that we call a micelle. The tails all point inwards, holding the dirt particle right in the center, while all the water-loving heads face outwards, towards the water. This traps the dirt, and when you rinse with water, the whole micelle just gets washed away, taking the dirt with it. Pretty clever, huh?
And here comes another exam hotspot. Why do we even use detergents? Well, in hard water, that's water that has a lot of calcium and magnesium salts, soap reacts with these salts to form a sticky, yucky substance called scum. You must have seen it. But detergents are designed differently. Their molecules don't react with those salts, so they don't form scum, and they work perfectly fine even in hard water.
Okay, final rapid-fire revision round. Ready? Let's go! First, carbon's magic comes from covalent bonding. That's sharing electrons. Its 2 superpowers are tetravalency and catenation. Isomers, they have the same formula but different structures. Remember, saturated means single bonds, and unsaturated means double or triple bonds. And finally, soaps work by forming micelles to trap dirt. Got it? Perfect!
So, after this super quick revision, tell me, what do you think? Are you feeling more confident? Are you now ready to walk into that exam hall and absolutely smash it, score full marks in this chapter?
Of course you are. I have full faith in every single one of you. You are all superstars. Just remember these key points, stay calm, and you are going to do wonderfully. If this explainer helped you even a little bit, please leave a comment below and share it with your friends who might also need a quick revision. All the very best for your exams, Bacho. Go and rock it!